Okay, welcome everyone. My name is Tonie Huizer, or my stage name in English is Tonie Hauser, because it's better to pronounce. Um, Let me start with a little picture. We have a picture over here. In this picture, every circle you see in the slide is a database. And every line, every arrow we see here is a connection and is actually a dependency. And if I look at this picture, I see a challenge. But if I look very close to this picture, I see the London Eye. Yes, my friends, what we have created and what I'm going to talk about today is how we created the London Eye. No, not really. We're going to talk about a brownfield project in which we implemented a DevOps, a database DevOps. And that journey, that's something we're going to talk about the next hour. Like I said, my name is Tonie Houder. I have my own consultancy firm. I work there as a whatever name you put in front of consultant. And these days it's DevOps. And why? Well, I like people, I like technology, and I like the combination of it. I like to talk about it. And these days I also write about it. And it's really the fun I experience in combining people and technology. And my focus areas in life are software, database DevOps, and whiskey. But the last part, whiskey, is actually a hobby. But don't tell my wife, Abby. Don't tell my wife. No one is watching, so that should be all fine. Is it recorded? Oh, just kidding. If you want to find me online, there are my handles. This presentation will also be exported as a PDF, and you can find it on my GitHub page. So what to expect of today's session? Well, like I said, I'm going to tell you about our transforming journey to DevOps. Is it continuous integration, or is it a continuous journey? Is it continuous deployment, continuous disaster? Well, I'm standing here, so I think you already know the answer. And I'm going to do that by telling you about the 4 DevOps phases that are defined. And normally, when I do the session, there's room for discussion. Well, the discussion with Abby, we already had that before this session. But if there are any questions, and Abby, as my monitor, please let me know if there are questions and if someone wants to interrupt me. And normally the interruption with a crowd is easier, and now it's virtually, so maybe hold your horses till the end for questions. Before we start, I will actually want to start with the end goal, so where we were working to. So the DevOps implementation we did also involved a database DevOps implementation. And the end goal was that we were working with a bunch of work items, which we will filter out to a proper backlog. And from that on, we started our sprint, the first phase of DevOps plan. And from that sprint, the developers will create a branch of the database, link the work item they committed on in the sprint to this branch, and via magic, personal database environments are provisioned. And it's not really magic, but we will come into that later. And then they will start the second phase of DevOps, develop. So they will build software, they will adjust things. And after they're done, they will create a pull request, and they will ask a colleague to review changes they made in the database. And we're talking here about a SQL Server environment, just to get the picture more clearly. And after the changes are reviewed by a colleague, then a migration script is made. The whole process I'm going to explain is migration based, and what that will mean will be more clear later on in the presentation. And this migration script, which is actually an immutable artifact, will go in the pipelines, and then we will enter the third phase of DevOps, deliver. Because this migration script is delivered to clones again for the tester, and his tester approved this change, only then the pull request is merged into main and the pull request is closed. But the same migration file, this immutable artifact, will go down the pipeline to staging and eventually go into production. And then we have 3 phases of DevOps: plan, develop, and deliver. And the world should be perfect from that point. It could be, but we also have the operate phase. And in the operate phase, we will look at production and we will check every night if production is still on the version we left it. Because maybe someone will alter production. No one altered production, Tonie. Yes, some people will alter production. Some people have the right to alter production. Why? Also will be explained later on in the presentation. But what we do every night, we do a drift check. We check if the database is still in the same shape, schema model shape, as it was as we left it. And if the drift check checks out that the database is drifted, we will create a work item and the whole process will start over again. So this is the end goal. Now, where did we start? Well, I got this picture from the Microsoft website, and the Microsoft has a few interesting things that I would like to tell you about. So when we start with DevOps, there's always this famous quote: DevOps is the union of people, processes, and products to enable continuous delivery of value to our end users. And I think almost everyone in this industry knows who said this. It's Donovan Brown. But it really meant something to me when I met Donovan Brown. This is in Takorama in the Netherlands in 2018. And here is Donovan standing in front of the crowd. And if you zoom in closely, you see here a bunch of people, and this is me listening to the master. And the master was explaining to me what he did for his team when he worked on Azure DevOps, on the Azure DevOps team, and what changes he made to make the team more successful. And I learned more on that event, Takorama, but listening to Donovan started the whole journey. But we today are going to start, just like Donovan, with plan. And Microsoft has a few practices you need to do to get to a proper plan implementation. And the first one is create backlogs. Well, I already showed you the end goal, so I think you know what backlogs are. But to explain it a little bit more, it are the work items that come from production that can drift the database, bugs, new feature requests, etc. And to keep track of your work, you need to create Kanban boards. And those boards, or other boards, dashboards, must be used to visualize the process so everyone is on the same page during this phase, the plan phase. And another thing that's pretty important is to use some kind of agile methodology, for example, Scrum. I'm going to tell you about my journey. And the journey starts with actually this plan board. This is how we started. So we just a regular board with some sticky notes, which wouldn't stick. So that's where we're using nails for it. And then it's evolved to this whiteboard. And the whiteboard even got better. But eventually, it didn't add up. It didn't work. And why didn't it work? And I can only say that now because I experienced it. And that's why I'm trying to explain it to you guys. Well, there's one important thing. And normally I ask it to the audience. But if you look here, the team is too big because all the people that are listed here, all the 3 or 2 characters are just abbreviations of people. The team was just too big. It was too big to do a proper sprint. Another thing that's now pretty stupid, but in the days we liked it, we only had 3 possibilities to plan work. It's today, tomorrow, or later. So our iteration path wasn't really fixed. We also had little involvement of the stakeholders. So we did work for the stakeholders, but they were not really involved in our sprint. And then there was the unrefined backlogs. So this is for a customer, and the item says issues. So I'm going to work later on TBO issues. It's not really clear what you're going to do. So how does your colleague know what you're doing today, tomorrow, or later? Another important part, we had no visible links or integration with the actually develop process, which we'll cover later on. Now it's time already for the first demo. For the demo, I like to use, maybe my monitor again. You see my screen? Yeah, it's now logging in again. I don't know why.
Good.
Yeah, thanks. So I'm now logged into an environment of a customer. And this is the board we use for the database DevOps. And on the left-hand side, you see the sprint burn down, which actually contains not much work this sprint. And that's because of the summer holidays. We have several tiles here with items, work items we query. And if it becomes red, then there's work to do. So we have 4 work items that don't have any tags. And if it doesn't have any tags, it's not good to track. We have some work assigned to me. We have some interesting links that we can use. And this is the start of a dashboard you can use for yourself. But these dashboards can also look differently. I have another one over here, which will also refresh if I open it. This is the deployment dashboard. This is made for deployment only. So if someone goes deploying, it will check these 2 tiles. So every application has a test and a deploy tile. So if there's still a test tile, you can never deploy. It's that simple. But here we have a test tile, but don't have a deploy tile. That's because the deploy task is for another sprint. And I won't cover them all because we only have like 1 hour. But we have several dashboards for several parts of the process. I'm going to switch back to another dashboard, which is not really a dashboard, but it's a Kanban board. This is what a colleague of mine created. All the new user stories will go into the new column, and eventually we will go from wait, refinement to in development and to production. And he also created some extra swimming lanes for a big project and for just maintenance. And this way we had more visualization on what we're doing. And if I switch back to this one, and I will go to my work items. And for example, I will make a new work item just for a test. So data left unattended test task. And I'll save this one. If I now will go back to my dashboard, you will see that the tackless work. If I click it, oh, it's not in the sprint yet. Yes, sorry. That's the live demo. Back to the slides. So, what we did, we are doing this now for 142 sprints in a row. And we're still evolving, we're still improving, we're still adjusting. 2 weeks back, I was in Bonn. I learned some interesting stuff on work items, which is something we're going to look at to improve even more. But the first thing we did, we split up the team per end user or per end customer, because the same team was servicing multiple customers. And by that way, the team was smaller. But the other advantage it had is that we could focus and involve the stakeholders, because before the same customer or customers which were operating in the same industry were in the same team. So involving the customers would be actually not handy because they're in the same industry. But now with a customer-focused team, it was possible to involve the stakeholder. People in the team got training in Scrum methodology, and we use better integration of tools. And what I mean with better integration of tools, I will show in a later demo when I link the work item to a branch I will create. And there it is. It's even mandatory to link the work item to development because else development couldn't finish. So if we look at the DevOps practices, we can easily check all the boxes because we're now creating backlogs, we're using proper backlogs, using Kanban boards, and we will visualize the process with dashboards. And the last part is the managing agile software with an agile methodology. So the plan phase is actually done, and then we look at the next phase, which is develop. Microsoft defines, again, a set of practices to up your game for DevOps develop phase. The first one is to choose a version control system that supports collaboration and work in parallel. The second one is automate repetitive tasks. So things you do over and over again, well, maybe automation can help you with that and save time. And another one is turn your code into immutable artifacts. And for software, that's simple. So you have like C# source code, you compile it and you have an executable. That's your immutable artifact. But for a database, it's harder. And I already showed you the end goal. So a migration file is this immutable artifact, but we will come with details later on. Back in the days, we were using SVN. And later on, we were using Team Foundation version control. But they both didn't do the job. And that was not just because of the technology. It was also because of choices we made back then. Because we had one big repository with all the code in it, which was not really a good choice. And it stopped us from working in parallel. So we had to develop a story one at a time. So no working in parallel. And the problem we had for the software, but also for the database, it was never known what code base was used to release the software. So for example, if you look at the .NET code, someone compiled the code on his computer and that executable went into production. So if he didn't commit it or tagged it or whatever, it was not clear what code was released. And for the database, it was the same because someone with rights on production deployed the database change, but it was that change at that moment in his SQL Server Management Studio open. And no one even knew what was released. So we had to fix this. But SVN and TFEC didn't have that much of automation or support of the community. Because if you look at the implementation and adoptance rate of these different version control systems, see that over time, this red file is getting higher and higher, and that's Git. And the rest is just decreasing. So we had to switch. We had to switch to Git. That was something also at Tagorama I learned. So we had to migrate. But how do you migrate a version control system of a complete company? That's actually hard. And migrating is just the first step, because if you migrate it, then you have to use it. And if you use it, you have to think about how to use it. And that's adopting a branching strategy. And then you have your branching strategy, but how do you name all your branches? So we had to come up with a branching naming convention. But this migrating actually, and I already said that, is not only technical, it's also functional. And why functional? Because we had this one big repository with all the customers in it, with all the projects in it. We had to split it up. we had to separate the components because in these days before 2018, a lot of components of .NET, and I know this is database focused, I'll still touch it shortly. All the components that were used in the solutions Visual Studio were copied into the software, copied into the source code. No NuGet was used before that. So this whole project was even bigger than just the database levels. But back to the database. If we sort it out functionally, then we had to sort it out technically. And this is the path we took. Which is actually strange, Tonie, because I see SVN, I see Git, I see TFVC, and I see Git again. Why are you doing this? Well, when you started a new Azure DevOps project or Azure DevOps server project, and you were running an old version, then version control was by default TFVC, because Microsoft believed in that days that TFVC was the standard and should be the standard. And we didn't do any proper research, so we ended up with using TFVC. But the only way to get from SVN to TFVC is to use Git. So we never heard about Git, so we just ran some scripts, then migrated SVN to Git to TFVC, and we thought, okay, we're done. But then we figured out, TFVC is not really the way forward. So then we migrated from TFVC to Git again. So if we did some proper research, we just stopped at the first Git, not the second Git. But hey, I'm here to tell about my journey, right? So what did it look like? Well, the application source code you see on the left-hand side. So we had a SVN repository per customer, and within the customer, all the projects were there. Also the shared components. And for the database, we had one big repository with all the database code in it of all the customers. But this is how we ended up. We created a single Git repository for every project, for every component. If we talk about application source code. For the database, we created a database source code project per customer. And that's mainly due to all the dependencies I showed you in the start of this presentation. But then the branching strategy. How to choose a proper branching strategy. And we don't have enough time to cover all the branching strategies. So I will just skip that and go to our, and actually my preferred branching strategy, which I also learned about at Takorama. And it was Edward Johnson who told me that. And it's called the release flow. And the release flow is used by Microsoft internally for a lot of projects. I recently learned that it's also used by Microsoft. Not how Microsoft meant to use it, but that's, I think I can fill another session about that, so I'll skip it. I will focus on the release flow, how Microsoft meant it, and how I learned it from Edward. Everyone can learn it from Edward because it's still on the Microsoft Learn page. The important thing on the release flow is that every topic, so every branch you make, every feature or bug is short-living. And if this branch will merge into main, it should be tested so that main is always in releasable state, which means that it can be a release, but it shouldn't be a release always, but it can be a release. What that means, I will try to visualize in a few minutes. And if you hotfix the release, yeah, I say hotfix the release because you want a release hotfixed and not main, you will cherry pick that fix into main. And again, I think a picture will explain it better than I'm trying now with words. So here we have main, and time goes from left to right. So a developer makes topic A, does some commits, and when he's done, he asks his colleagues to review the changes. He asks the tester to do the testing, and when the test is successfully, it gets merged into main. Then at a certain point in time, the customer calls, and the customer says, "Hey, friends, sprint 97, give me a release." And because main is in releasable state, you will then create a frozen copy, or it's a branch, and call it release sprint 97. And time evolves, and topic B is created, and some commits are done, and topic C is created, and it's again end of the sprint. And at that point in time, sprint 98 will contain topic A, because it was already in main, and it also contains topic C, but it will not contain topic B because it's not tested yet and not released, not merged into main. But this customer doesn't always call for the good things. It also calls because at a certain point in time, and time evolves, as you can see in the picture, topic B is now already merged into main, but he calls because there's a problem with sprint 98. And this problem must be fixed in release branch sprint 98. Because if we fix it in main at this point in time, we will also include topic B. But we don't want to include topic B because we just released sprint 98, which this didn't contain topic B. So we have to fix the hotfix in sprint 98. And we just fix it and merge that back into sprint 98. But it doesn't stop there, because if we would stop there, the bug will still be in main. And this is where the cherry picking part comes in. We will then cherry pick that change and put it back into main. And that could be easily just merging, but there could also be some change that's already done or conflicting with something that happened in topic B. So that's why fix it in the sprint release and cherry pick it into main. That's all fine, but now we have to name these branches. And this is what we came up with. So we have in blue the branch category. There's in red, and only if it's applicable, the hotfix release. So what release it is hotfixing. Then there's the internal ticketing system, so Jira or whatever you're using. And then classical case description, which a developer is free to use. And the hotfix, which is the deviation of it all, so let's start with it, will be then hotfix, which is hotfix in sprint 100, MMS, which is the ticketing system and a number, and then firefighting, all separated by dashes. For the normal topic will just be topic, ticketing system again, the number, and my description. And my description is, of course, not really good, but it's just my description. Well, and then, of course, the release. And as you already could see in the picture, it will be release and then a unique identification. In our case, sprint 100. And a word of advice here is that if you use Azure DevOps and you think, well, I don't like sprint 100, I would like cities of America. And I will start with Boston and then Chicago and then all of a sudden Atlanta. Well, then you get a problem with the alphabet because Azure DevOps will sort all those releases alphabetically. So choose your non-numeric sprints wisely. And that's why we just keep it with very dull, boring numbers, but it will sort out correctly. And it links back to the sprints the guys and girls are working on. So if you compare Git to SVN or TVC, what we've been used for, we have now one repository per solution. We work in parallel because we could branch, and we spend less time in managing version control. But above all, and that's, I think, the most important part, it was always visible what is released. So we could take only one DevOps practice box for develop at this point in time. We're still looking at automating repetitive tasks and turning code into immutable build artifacts. So let's continue, Tonie. What do you mean with repetitive tasks? So I only took a part of the process, not to bore you with all the old processes, but to explain just a tiny bit of a repetitive task we now got automated. So this was the old way of working. So without personal databases for our developers. We had this one big shared development database where all the changes went into. And whenever a change needed to go into source control, you had to filter out your own change because it was a shared database. And whenever this change went into version control and we wanted to deploy it to the shared test database, we had to filter out again this specific change because we were not using branches. So the change will just go into master and you just have to filter out it again. So when the tester is done and he likes to compare his test environment with the production snapshot, there could be other changes in the test database as well. So he had to filter out again his changes. Well, I think you get the point here. There was a repetitive task, namely filtering out the same change over and over and over again to eventually get the sync script you want to put in production. And this is just an example, but the answer for this is version your database. And there are several systems for that. And if you version your database from 0.1, you had this sync script all along and could migrate it or use it down the pipeline to provision your shared test database and to update your production database. So some points I like to point out for automating repetitive tasks. And the example was already shown in the previous diagram. Look at your process, talk to your people, standardize that process, and then start automating. And if you start automating and use pipelines, start locally with PowerShell scripts or Bash scripts or whatever, but automate all your changes locally. And when you think you're done, you're not done yet, because then you put in logging and then you go to the pipelines. Because if you want to debug a pipeline, it's hard. It's very hard. And everything is wrong and it's never your fault. And in the end, it's all your fault. And so listen to Tonie and start locally, add a lot of logging, and then use the pipelines. So demo time again. If I will switch to this repository. So I have a repository here, and this is actually the production environment of this repository. So all the co-workers in my team that are now working, stop doing what you're doing and don't touch the environment. It's perfectly safe because we're using branches. What? No, not drop all things, Peter. So on the left-hand side, you see all the databases, and those are the databases that are versioned from this London eye picture. And for the people that are counting, those are not all the databases in the picture, Tonie. That's right. That's because of number of databases are from third-party vendors, and we cannot version them. We still use them, but we use them another way. We use them as clones, but we don't use them as a version database. So if I open the first folder, you see the ATS ASA framework database, which consists out of two folders. One, the schema model, with some recognizable things like tables, store procedures, etc., etc. And the second one, migrations, which contains all the versions of the database. And it starts with a baseline, and on top of that, a version is added, a version is added, a version is added. The tools I'm using for this is Flyway, but you can use any tool for that supports the migration workflow. So if I now go creating a branch, which we can use topic MMS or ticketing system, and then just 2024, and then data left and attended. I can create it. But what's important here and not mandatory at this point is to link the work item. So I have here my DLU test task, which I can link at this certain point. I can do it later. If I do it later, for example, in the pull request, it still is valid for my checks I will add. We are adding two merges into main. But if I do it at this point, I don't have to think about it anymore. So in the background, the new branch is created, but the pipelines are also fired because it's now creating a build of this specific topic. And I think if I go to the next one, yeah. So if I refresh this page, you will see that for topic MMS 2024, DLU, the build is running. And what this build is doing isn't that special, actually. What we're only doing, and I will show that in another build that's already run, backspace is working. So for example, this one. If I look at this artifact will contain, again, all the databases we saw, but this time only the migration folder, because the schema model is not interesting at this part, because we want the migration files, these immutable artifacts, to go down the pipeline. So that's the only thing we want in the artifact. And I think the build is done now. Yes. The other thing that stands out is the naming. So the naming contains a unique build number, and after that it contains the branch name. So the naming convention is also important and used in other steps in the process, so it can always link back to your original task. But in this case, we already linked the work item to it. Okay. So we use a pipeline to generate this immutable artifact. We just saw that. And in case the demo didn't work, I got some fancy screenshots, which I took 20 sprints ago, so to see, sprint 125. And we will apply this artifact to all environments. So, well, that's something we will see in the deliver phase. But we'll see that in a few minutes. So the DevOps practices, we can check all the boxes now for develop. But the next phase, we already talked about that, is the deliver phase. How do we deliver this artifact to all our environments? So Microsoft says one of the deliver practices is automate your delivery process. But don't stop there. Also use approvals. So what that means is that we use automation, but there are still people involved to approve certain steps. And something we stopped at develop and we will take over on deliver, release this artifact to different environments. So our previous workflow was actually, if you look at the software, we copied the build from a share, which was built on someone's computer somewhere, sometime we didn't know. And we did the manual deployment of database changes just from SQL Server Management Studio or from a comparison tool like SQL Compare. Oh yeah, and then there was the configuration, and we were just hacking on site, so everything would work. Oh yeah, and if it's okay, we just send out a phone call or a Teams message, and we said it's okay, and that was the informal approval. But if you look at the practices, those workflow items I see over here don't work anymore. Oh, and of course, above all, we had this shared environment. So we had one database for development for all the developers, and we had one database for all the testers, which isn't really working if you work in parallel. So what we did improve we wanted to test in parallel, just like development. And what I mean with development is a developer with a Visual Studio, which will clone his C# code, works kind of in parallel on his own computer. And we wanted just that, but then for databases. We want to make use of the disposable environment. So if we're done with the environment, we want to throw it away. And to get rid of the informal improvements, we want to implement the pull request workflow. It's a long set of words behind each other, but it's really a thing, the pull request workflow. You can look it up on learn.microsoft. We didn't invent it. It's a common practice, and it's pretty interesting. I will have another diagram about it in a few slides. So to achieve all our goals, to achieve these improvements, we had to introduce database clones. And it could easily just be a cloning technology from an external vendor, or you could easily just invent your own cloning technology. I wrote an article on that on SQL Server Central, so it could be interesting, but it could also be containers. See cloning as just a broad topic by getting databases for yourself in a quick way, and a quick way to dispose it. So we start using a cloning technology from a vendor, which we happen to be just here, Redgate Yay. And that's a pretty smart technology. But what we did, we automated the usage of this technology. And there's a REST API for it. If you want to know more about REST APIs and you were not awake this morning, John Martin did a topic on that. But what we did, we went a bit farther. We wanted to automate the creation, but also the housekeeping, because if you create stuff automatically, in the end of the day, you have created a lot of stuff, but someone has to do the housekeeping. So the problem with that is that if you work on a task and you have your special personal database available, your clones, then suddenly someone comes in and says to you, "Oh, Abby, you're working on topic 1, 2, 3, 4, 5. Sorry, man. You have to change priorities, so we're going to do something else." So what the team invented is a kind of stashing of all the database they're using. It's kind of Git stash, but then for databases. And the fun thing of that, it works only on personal instances, so in a personal environment. That's mandatory, but it was not working on your system. We made that available through Azure DevOps. It's maybe a lot to comprehend with just one slide and 4 bullet points, but what we did, if you follow the system in Azure DevOps, so if you create work items, link it to your branch, and you release your work, in the background, we created pipelines that will look at your environment, create your clones, and if you're done, it will throw away your clones. But if you change priority and you already have clones, what will happen then? Well, let me explain again with a little diagram. So here's my developer working on his first task, topic my first task, and by magic, or actually just by pipelines, his dedicated databases are provisioned with clones. And he will start working, and life is fine, and life is good. But then all of a sudden, the manager comes in. He says, "We're changing priorities, man. Something happens. I got a call from customer XYZ, and you need to do this and that." At that point in time, you will switch over to Azure DevOps. You will create a new branch and call it topic priority blah, blah, blah. Because it's a manager and they will come in, and most of the time you hear blah, blah, blah. So I think that will be the perfect topic name. And by magic, or again, pipelines, a new thing is happening. Because what's happening is that the pipelines start a PowerShell script, which will look at your environment and will see that you already got a database environment provisioned for my first task. And it will then rename all your databases to database name underscore the task you're working on. So then the normal provisioning will take place, and you will have two sets of databases on your personal instance. One renamed after my first tasks, and the other one with the normal database names. And why bother about these names? Well, if you start applications, they will expect a certain name of a database. So you work on priority blah, 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 you develop, you create your pull request. Well, that's the whole workflow we saw in the beginning of this presentation. And when you're done, then you switch back to my first task. And this whole part is something we automated for our developers and testers, because if they did this by themselves, they could easily forget some steps. So we looked at the process, we talked to the people, and then we automated this process. And at a certain point in time, and this is a screenshot from production, this could be your environment. So with 5, yeah, I can still count, with 5 instances of your database. So there was a priority change 4 times before you could finish one of your other tasks. And that looks maybe odd, but if you look at your work, when could you ever just finish a task without getting interrupted by some priority? And we could say, oh, that's not happening, and we always finish our work, but that's not reality. Reality is this. And if this is the reality, then we have to create automation for it to work in this reality. Another diagram, and I know it's a lot to digest, but let's park the part of the clonings and the switching and go back to the other part, and that's the pull request workflow. So before we implemented this, it was all informal, I said. So I will just call up Abby and I said, hey, I'm done and I want this and want that. That's why we started implementing the pull request workflow. And you see here the tester, and the tester is waiting or is calling the developer and say, I want to test. And from that point in time, everything will happen sort of automatically. Because after the developer creates a pull request, as a DevOps will inform the reviewer. The reviewer will do his code review, and he approves the pull request. He won't complete it, he will just approve it. But he will push the button autocomplete. And from that point, a pre-merge build is created. And the pre-merge build is actually just the build of your topic, but it also includes any other changes that are already in main to prevent any problems you will get when you want to merge. And this pre-merge build is queued and released, and automatically by Azure DevOps, the tester is involved. And if the tester passes the release and accepts the release or approves the release, only then the pull request is completed. Because a successful build is one of the requirements of closing a pull request, but also a successful release is one of the requirements of closing a pull request. By implementing this workflow, we achieve the goal of getting track of what is tested, what is accepted, without the informal approvals. And you see here a summary of it, and I was already covering most of it, but the last bullet point is pretty important. So we automated a lot of it, less manual, but it's still important to call your colleague. So once and again, just to communicate with your colleague, say, hey, how is it, and what you're doing, and not rely completely on the automation. We're all people. So, and looking at the time, I think we have some time for a small demo. So what I already said is that the release of these artifacts will be over and over the same as again. And from this point, I can easily create a release of the branch we just created in the previous demo. So if we'll just create a release with the artifact we just talked about, so containing all the migration files and not the schema model, just the immutable artifacts, just the versions of the database. On the background, and there should be a pop-up here, a release is created. This release, and this is one of the approvals, is waiting for approval. And why is it waiting for approval? I'll show you. It's waiting for approval because Azure DevOps wants to know who approved this. And because Tonie Huizer is approving it, the environment of Tonie Huizer is now provisioned in the background with all the clones and updated, migrated to the version from the artifact. But if Abby, Niels, Patrick, or someone of the team approved it, then their environment was provisioned. And I will open this just to show some flashy PowerShell script that will appear or not. And here we see some of the PowerShell in work. Here we see the cloning of the databases. And the next step will be the provisioning, or sorry, the migration of those databases. And this topic, this session is about my journey, and we don't have enough time to look into this technically. But if you will Google my name, I've written an article or 2 or 3 or some more about this topic, revealing the techniques I've been using. And you just happen to come to redgate.com, and I've got an author page over there. Enough of the Redgate, yeah. So releasing this to my environment, if I will switch back to the thing is happening. Normally, when you look at different environments or stages, you see like develop, test, staging, production. But here we see a strange situation with DMZ and production. And I won't go into too much details, but the DMZ is really a demilitarized zone. It's an environment between 2 firewalls where the data resides at the site of the customer, because that was one of the requests of the customer. So the data doesn't leave the site. And within the DMZ, you have several roles. So you can start it up as a developer, this release, or the next time you're a tester, you can start it up as a tester. And by switching the databases with the stashing mechanism, this DMZ is actually dev, test, and staging. Okay? So we can now work in parallel because we have branches and we have database stashing. We will use housekeeping to get rid of our environments, and we implemented the pull request workflow. So I think we can tick all the boxes of the deliver DevOps practice. And that's okay because we still have 7 minutes and we're now in the operate phase. So operate, which is the final phase of DevOps, and then the cycle continues again, of course. So Microsoft says in operate, we expect monitoring and troubleshooting. But we also expect from you to secure your knowledge. If you troubleshoot something, so if you get a call, something is wrong, the first thing you ask yourself, what has changed? Something changed, hardware, database, software, people, and who signed up for this change? And where did this change come from? So these 3 questions can now be answered because of the other phases we already successfully implemented. Because where did the change come from? We linked it to a work item. Who signed off on this? We have approvals in our process. And what has changed? Well, please look at your source code. Then you can see that. Look at the pull request. But as I already said, sometimes people just hack into production. And when there's an audience, I always get the question, but just remove the rights from the developers. That's a good answer or question or statement. But the people that are altering the production database, is actually the customer. So customer, if you're listening to this video, I'm talking about you. So what we do, we integrate a monitoring system in every delivery we do. And every night, we look at what we delivered and compare it with how the database looks then. And if something is wrong, we will create a work item and we will put that work item in the backlog. So the next morning, you open your dashboards and you see database drift, work to do. And this technology, and the patent is still pending, but we call it snap and drift. And with snap and drift, and again, a diagram, Tony, no more diagrams. Well, still 5 minutes, and I promise you, this is the last diagram. So at night, we do a snapshot, and before and after approval. And the snapshot, we use a technology that's incorporated in SQL Compare. It's called SQL Snapper. And with SQL Snapper, we create a snapshot of the schema model. So it's not a database snapshot, so there's no database in it. It's just a snapshot of the schema model. We will store this snapshot. It's a file on disk. And we will compare that every night with how the database then looks. And we have here several. So is it post-deployment? No. Is there a previous snapshot available? Yes. Then it will use SQL Compare to compare the snapshot of last night or last release with how it looks now. And if there's a difference, notify the team and keep the snapshot as the latest. But we do the same check post-deployment, because then we store the latest version of the snapshot. I see 2 minutes on the clock, so I will continue, but I think you get the point. So checking some boxes. We still have secure knowledge. And secure knowledge is something we have to ask the team and say it every time. Please document. Document in your work items. Document in your wiki. Document in your commits. Document, document, document. Because if you document stuff and if you link it, and that's again the mandatory work item link, you can ensure provenance. And provenance is a fancy English word just to prove what has happened. So another thing, besides linking the work item and writing down documentation everywhere, is using extended properties. And with another, I shouldn't say Redgate yay again, right? Yay, Redgate, SQL doc. Just use extended properties and convert them to wiki again. And all of these things can then be searched through Azure DevOps with some kind of Elasticsearch. And I have a discussion with someone, is it Elasticsearch or not? But it's a pretty good search mechanism that will search through your work item, through your wiki, through your code to find answers to your question. And with that, I can check both of the boxes. And I think that's time for the takeaway, just in time. If you do a proper DevOps, please do it in the proper order. People, processes, and tools. Look at your team. Look at software development. Do the DevOps implementation there. And then look at your database process.